Welcome to this comprehensive 10-minute training video designed specifically for beginners diving into C# programming. Today, we're focusing on essential techniques for null checks, data validation, and assertions to help you write robust, error-free code that stands up to real-world challenges. We'll break down each concept step by step, starting with why these practices matter and moving into practical examples you can apply right away in your projects. In this session, we'll thoroughly cover the fundamentals of handling null references to avoid common pitfalls, ensuring data integrity through various validation methods to keep your application secure and reliable, and utilizing assertions effectively for debugging and rigorous testing. By the end, you'll have a solid understanding of how these tools integrate into modern C# development, with tips to make your code more maintainable and less prone to runtime surprises. Writing robust code is absolutely crucial for maintaining application stability and delivering a seamless user experience in any software project. Unhandled errors, particularly the dreaded null reference exception, can cause unexpected crashes, data corruption, or unpredictable behavior that frustrates users and developers alike, often leading to hours of debugging time that could be avoided with proactive measures. Let's begin our exploration with null checks, a foundational skill in C# programming. A null reference occurs when a variable is declared but doesn't point to any actual object in memory, which frequently results in the infamous null reference exception if you try to access its properties or methods without verifying its state first. Understanding this concept is key to preventing those runtime errors that can halt your program unexpectedly. In traditional C# development, programmers relied on straightforward if statements to explicitly check for null values before proceeding to access any members of an object, such as if myObject do something. This defensive approach effectively prevents runtime errors by confirming the object's existence in memory, ensuring your code executes safely even when data might be missing or uninitialized. Fortunately, modern versions of C# provide more concise and elegant ways to handle potential nulls, reducing verbosity in your code. The null conditional operator, denoted by, allows you to safely access members or invoke methods only if the preceding object is not null. For instance, myObject. Property will return null instead of throwing an exception if myObject is null, streamlining your logic significantly. Complementing this is the null coalescing operator, which elegantly provides a default value when an expression evaluates to null, acting as a reliable fallback mechanism for scenarios involving missing or optional data. For example, you might write string result equals user input, default value, ensuring that if user input is null, your application uses the specified default without any additional checks, promoting cleaner and more readable code. Taking it a step further, C number 8 introduced the null coalescing assignment operator, equals, which assigns a default value to a variable only if it's currently null, combining the check and assignment into a single, efficient operation. Consider myVariable equals new myClass. This initializes myVariable with a new instance only when necessary, avoiding redundant assignments and making your code more performant in loops or repeated evaluations. With the advent of C number 9, pattern matching enhancements like isNull and isNotNull offer a more expressive and readable alternative to traditional null checks, integrating seamlessly into conditional logic for better flow. For instance, if /* proceed */ reads almost like natural language, improving code clarity and reducing the cognitive load when reviewing or maintaining larger code bases. Moving on to the next pillar, validation is the process of ensuring that incoming data meets predefined criteria before it's processed or stored, which is vital for upholding data integrity, preventing security vulnerabilities like injection attacks, and maintaining the overall reliability of your C# applications. Without proper validation, invalid data can propagate through your system, leading to errors downstream that are much harder to trace and fix. At its core, basic validation in C# often employs simple if statements to enforce conditions such as checking if a string is not empty with if, verifying numeric ranges like if, or confirming required fields are populated. These straightforward checks are quick to implement and ideal for simple scenarios, providing immediate feedback and halting execution early if criteria aren't met, thus safeguarding your application's logic from bad inputs. For a more declarative approach, data annotations from the system.componentModel.dataAnnotations namespace allow you to embed validation rules directly onto model properties using attributes, making your intent clear at a glance. Examples include required, to ensure a field isn't null or empty, string length, to limit text input, and range, for numeric constraints. These attributes integrate effortlessly with frameworks like ASP.NET, automatically validating data during model binding and reducing boilerplate code in your controllers or services. When dealing with intricate validation needs that go beyond basic attributes, libraries such as Fluent Validation shine by offering a Fluent, shinable API that keeps validation logic separate from your domain models, enhancing testability and flexibility. In practice, you define rules in a validator class like rule_for_not_empty.email address, which can include custom messages and complex conditions, allowing for sophisticated business rules without cluttering your entity classes. Wrapping up our topics, assertions serve as declarative statements in your code that a particular condition must hold true at runtime, primarily aiding in debugging by catching assumptions that turn out false and in testing to validate program behavior. They're not meant for production error handling, but are invaluable during development to enforce invariance and expose logical flaws early, saving time and frustration in the long run. One of the most accessible assertion tools is debug, assert from the system, diagnostics namespace, which evaluates a Boolean condition and, if false, immediately halts execution in debug mode while displaying a customizable error message to highlight the issue. For example, debug, assert, acts as a safety net, helping you pinpoint exactly where your code's expectations diverge from reality during the debugging process. In the realm of unit testing, frameworks like NUnit provide a rich set of assertion methods to verify that your code produces the expected outcomes under controlled conditions, such as assert .are equal to check value equality or assert is true for Boolean states. These assertions not only confirm correctness, but also generate detailed failure reports, including stack traces, making it easier to iterate on your tests and ensure your C# codebase remains reliable as it evolves. To elevate your null handling, always prioritize modern C# features like the and operators to minimize boilerplate code and enhance readability, while enabling nullable reference types in your project file with nullable, enable/nullable to catch potential null issues at compile time rather than runtime. This combination empowers the compiler to warn you about possible null dereferences, fostering safer coding habits and reducing the incidence of null reference exception in your applications from the outset. When selecting validation strategies, tailor your choice to the complexity at hand. Opt for basic if statements in lightweight scenarios for quick, inline checks. Leverage data annotations for straightforward model validation that aligns with MVC patterns. And turn to Fluent Validation for intricate, business-specific rules that require customization and separation of concerns. This targeted approach ensures your validation is efficient, scalable, and aligned with the architectural needs of your C# project. Remember, assertions are best reserved for conditions that indicate a programming error, scenarios that should never occur in a correctly implemented program, such as internal state inconsistencies or violated preconditions, allowing you to detect and diagnose bugs during development phases rather than letting them surface in production. By strategically placing them, you create self-documenting code that communicates intent and facilitates collaborative debugging among team members. In summary, mastering the art of null checks, validation techniques, and assertion strategies forms the bedrock of writing reliable, maintainable C# applications that perform consistently across diverse environments. From preventing exceptions with operators like and to enforcing data rules via annotations and libraries, and using asserts to safeguard logic, these practices collectively elevate your code's quality and resilience. By consistently applying these techniques in your daily coding routine, you'll not only improve the overall quality and robustness of your C# projects, but also create software that's more stable, user-friendly, and less susceptible to the common pitfalls that plague novice and veteran developers alike. Thank you for joining this training. Now go forth and code with confidence.